Okay, let's do our fourth lecture. We have been through some labor issues, thinking about hiring labor, selling labor, thinking about those kind of details. And I would like to, at this point, reset. I want to go back to the model without the hired labor so we can consider a different alternative, a different track for bringing in more information. So let's reset back to 1,700 hours of labor available. It's all family time. So I am going to get rid of the 900 hours that we started with that we said actually show up as hired labor. We're going to drop that. 600 acres available. The objective coefficients are going to stay corrected. So these are going to be 171, 170.75. We investigated all the details on the labor side. Now let's focus on the land and the activities and how they work together. And so for that, I want to go back to the budgets. So in these budgets, we have all kinds of information. So we went back to these originally to get that labor pulled out, to use this information separately instead of just going all the way to these bottom line measures that someone put together and said, yeah, this is how you should make comparisons, right? I mean, this is a pure budgeting comparison. Account for everything possible and give the bottom line number, and this is the higher return when you account for everything. It had a couple of important assumptions. The $6 assumption and the fact that some of the family labor is being costed at that amount means that we should have reconsidered, and we went through all of our models. So I guess simple model, S model labor 1, 2, and 3 were the changes we made to get to there. Well, now we're going to reset and come back to this model. S model SEQ is the one we're going to use in this, where we say 1,700 hours on the right hand side, 600 hours, acres of 600 acres of land. And I want to use some more of that information from the budget and think about what are the different things that use hours of labor and variable costs. So they're inside of here, some revenues and some cost terms. And so what are the different sort of sub-activities within corn production that use up time and use up cost, that attribute cost to? And so in that budget, we see that every one of these. So on the input and cost side, we had planting hours and planting variable costs. So for corn versus soybean versus wheat, you see there's an allocation for the time of 0.45 hours to do the corn planting, and a variable cost amount of $60. For harvest, 1.45 hours, and the variable cost of 100. And so if you do all of those, you'll get all these different measures. And then what I'm really interested in, though, is this unallocated time. So the plowing and the disking, one of the reasons they're not specific to the crop is they're done ahead of time. They are, you pass over all the land that's going to be cropped and under these assumptions, and you do plowing, then disking to do land preparation. So it's not really allocated specifically. It's just when you do the full cost measure, you'd want to get, if you're going to give someone a predicted gross margin that would cover management, capital usage, or capital, the money that can give you return on capital plus land, this is the number you'd want to give them. And so that's where those numbers come from, but we have the information, we have a model structure that might let us use more. So each of these activities, over here are the budgets again. Planting costs plus hours, harvest has both, plowing and disking have both. And these plowing and disking are designated as land prep. They could unambiguously, right? There's no problem with adding those to the per acre budget. They have the same impact. But we might be able to make a model, a sequenced model, that says first you have to prep the land for growing the crop or for planting to harvest activities. So once you prep the land, then you can do the allocation. Since those costs aren't really allocated, we could actually build that up as a sequenced model. The way to do that, how would we do it? Transfer activities, balance equations, that's the answer. So we can build up a sequence out of these sort of transfer and balance conditions. Okay, if we looked at the budget, we would see that every acre that gets plowed or disked costs $10 per acre. And so if you plow then disk, it's $20 per acre in the total variable cost. And respectively, it takes 0.6 hours out of the labor to accompany the plow and 0.5 hours to accompany the disc. And so those are the labor draws for plowing and disking, no matter what crop you're planting. And if we wanted to think about a balance or a sequence that we might put into this, then we might think of the following. So plow first. No acre can have any other activity without first being plowed. And so that gives us an entry point to consider the land use, right? So the first thing that says we're going to use the land is plowing. It's the initiating activity, and so it takes up the 600 acres into its constraint. You can't plow more than 600 acres because you don't have that much. And if you force everything else to follow, right, the only land that matters to all the other activities is land that has already been plowed, then this constraint is going to pass over the 600. It's going to pass over the land limit. And it'll also feed back. If you don't have enough crop value in the model, if the model doesn't, if they're not enough good enough returns to justify planting all 600 acres, that will pass its way back up because the plowing incurs a cost on us and we'll plow less than 600 acres. So there's nothing about this. It feeds forward and it feeds backward. That's the virtue of a sequence constraint being carefully put together to work. Once you plow an acre, you can transfer it to disking, to the disking activity. There'll be a balance constraint there. No acre can be disked until it's been plowed, and every acre that gets disked must have previously been plowed, and so that balance has to hold. Once an acre becomes disked, right, it becomes fully prepared. It's a prepared acre, and so you can transfer those to the actual crop activities, and we're going to leave the crop activities as plant to harvest. So we're going to have all the planting and harvest together in those. And then we add the variables for plowing and disking, and they have to be non-negative. And so let's look at the algebraic change to the model. It's going to be significant. So we have our three crop activities. They stay the same in terms of variable names, but the plowing activity is also on an acre basis, and we're going to call that PL, and DK is going to be the disking activity, also on an acre basis. In our objective equation, we need to add those two activities, and each comes in with that $10 cost per acre. So every time you plow an acre, you incur that $10 of cost, that negative revenue. Same thing with disking, right? So this total, this line up here, is the land prep cost. And so I've separated it off, even though this is one equation, though. This plus follows on and says the next thing, right? So it's just a long equation. And then the constraints, we go down here, and like we said up here, you have to plow first, and the limit on plowing is 600, so plow must be less than or equal to 600. That's our plowing constraint. Then we need a balance or a sequence constraint. So this balance constraint, you can't disk something until it's first been plowed. It says transfer a plowed acre down here to the disk sequence, and then the activity disk can be used, right? So if you want to disk something, it first must have a 1 in the plow activity to be transferred down here, and that gets a 0, right? So that's the balance condition. You have to plow it. It provides the negative down below, the demand for disking, right, causes this to go positive, and every time you try to push that above less than or equal to 0, the constraint says, okay, to balance that off, you have to plow an acre. So it kind of works backwards. And then we have our third constraint is another balance constraint. It's a full prep. So that's not just a land constraint, it's fully prepared land. It's land that's ready for crop activities. And so XC, XS, and XW, all three cropping activities enter into that one. But if you want to do this, and we have 0, you want to plant an acre of corn, well, the sequence constraint, or the sequence of the model, says first you must disk it. Okay, so if you want this to be 1 or 10, then that tries to go above 0, which isn't allowed by the balance constraint. So to match off that 10, you need a negative 10 here. You need to have disked 10 acres. Well, that backs you up to this constraint where you have a plus 10. To get a negative 10 here, you need a plus 10 here. And before you can disc these 10, you have to keep that from going above, right? To keep that constraint holding, you need to commit 10 acres of plow time or plowing activity, and you do that up here, and the limit will stop you at 600. So it works its way back. So you want to do the crops, you got to disc first. You want to disc because you want crops, you got to plow first. You don't want to plow, well, you can plow, you can plow, and you can plow, but not more than 600 because that's the acre limit. So that all fits, that all works out, and then we just need to add the labor constraint. And the difference here is we're going to take the labor activity, the labor commitments that were originally, in the corn, soybean, and wheat activity. We're going to split them off, and we're going to say that those labor commitments happen with the plowing, right? So we had these coefficients up here, 0.6 per hour, 0.5 per hour, and we need to account for those. So this falls from 3 down to 1.9 because the plowing and the disking are now separated off from the activity of corn plant to harvest. We have non-negative variables for plowing and disking. They need to be 0 or greater. And then we have one more change. Because we moved these costs over to plowing and disking, every one of these coefficients go up by 20 because our budget said calculate all the costs except for labor and put those in here. And now we're saying calculate all the costs but labor, and also don't count plowing and disking. Those are going to happen in a different activity. And so the gross margins go up to 191, 190.75, and 170.5. So that's the algebraic form of our model. You have the sequence model in your spreadsheet, and here's what it looks like if you solve it. So it's what do we have? The spreadsheet model has a complete accounting of the land prep. 2 activities, one for plowing, one for disking. Those have to be completed to pass over land available for corn, soybean, and wheat production. And that happens down here in this balance condition. Left-hand side versus right-hand side, you have a 600, using all 600 acres of land. The balance condition holds, This one probably didn't get a tolerance to perfect 0, but it was close enough for solver to stop. But there is some some parentheses there. Don't know. So this all worked out. We get our model. We actually get the solution we've had several times before. You should be planting a mix of corn and soybean, right? When it's only family labor, when you can't buy and sell labor in the model, the thing to do is mix corn and soybean. That's the only outlet for family labor. You need to get returns for it, and so do that. So we have those things in here now. Why is it important if we're getting the same solution? Well, we can independently analyze those now from the rest of the model. If plowing and disking are important concepts to think about for analysis in a crop model, then having them separated could be very useful. And one way to think about it might be it opens you up to thinking about what a no-till activity is. So we're saying these all have to be plowed and disked. What if there was a second version of corn that was no-till corn, right? You could plant it and get away with only disking the ground, or some other lower prep, or pure no-till, right? No prep. And that would be a competing activity to produce corn. It would use up land, and it would save some costs on this side, but it might have some extra costs, chemical or other kind of prep, in the corn coefficient, right, on the activity. And so you could do that analysis. You could even do other analysis if you were thinking about things like runoff or erosion, right? So maybe you have erodible land that you're not allowed to plow and disc, and so having those separated out to think about the alternatives there. And then of course, if you have excess capacity, if you actually own the plow and the disc and you have excess labor in some certain time of the year, you might be out there plowing and disking for other people because you have capacity to keep doing it. So it opens up avenues for analysis there, even though we're getting the same solution we had. But we want to move on, and so we've done this transfer. So we've showed you how to sequence things, right? So this is the concept. That's the main learning objective here. You plow, when you do that plowing activity, you generate a -1 for every variable unit. So 600 times 1 here uses up this constraint. 600 times -1 makes a -600 down here, which allows you to disk 600 acres. Disking 600 acres adds a -600, 600 times -1 here, pulling this down below 600, allowing you to use the land for corn, soybean, and wheat production activities, or in this case, just corn and soybean. And that's how the sequencing works. You can do it on anything, right? We've done, well, not, think about like a brewer or something, right? Where you first sort of have to ferment, and then you have to do some bottling, and then maybe you do quality control. Well, one line can't complete its work until it's provided things by the other. And so if it's a constant production line, then maybe the sequencing doesn't matter too much. But maybe there is, you have to complete a full batch of brew before you can bottle, and maybe the amounts matter enough that having those in sequence that you must have some threshold met before you can initiate the second level activity. Any of those could be important for sequencing. Definitely production lines, especially when things are produced as batches. Having some sort of full batch prep before anybody gets to start on the second and third lines can be very important. Now, it's possible those second and third lines move without much bottleneck, so that they don't need to be separated. But I did want to talk through the sensitivity report, since that was a big topic last time. We should look at how the sensitivity report is impacted by adding these sequences. Right? So you add in this constraint, and they're kind of weird looking, right? So you end up with a 0 and a 0, and we might want to know what it means to get the shadow prices for those. So I print the full sensitivity report here. The values are rounded to the whole number. I'm not sure why I did it, but I did it. And so you end up with this labor shadow price being 1 when it's really some like 0.6 value or something. And so you lose a little bit of the detail. I shouldn't have done it, but I did. Remember, we can read the final value column to be either the activity level in the model for the variables. So 600 plowed acres, 600 disked acres. Those match up to the total plant and harvest acres here. The final value for constraints tells you the left-hand side. So we plowed all 600. That was our limit. The balance conditions will always be 0 versus 0, right? If you wrote a balance constraint or a sequence constraint with a balance condition on it, and you didn't get zeros, you've got a mistake. And hopefully you found it before you get to the shadow prices or the sensitivity information. Look at them a little detail here. The shadow prices we talk about just a little bit here, just because we want to acknowledge they can't respect the importance of the sequencing balance constraints, right? So that sequence process is a linkage, right? It's almost a dynamic linkage across constraints. But Excel and the simplex algorithm that it's using and solver doesn't really understand that. So when it goes to calculate the shadow price for fully prepped land, it says, what if, instead of having 0 over here for your balance constraint on the right-hand side, you had a 1? What if you were just gifted 1 acre of fully prepped land? What would you pay for it? Well, $190 is what you would pay for it, right? That's what it's worth, right? That's a rounded off value, but that's what it's worth in the production plan. And that makes sense, right? Because about $190 is what corn is worth to us. And so if somehow we had that happen, that would be great, but it's really not a very useful shadow price, and you could back your way up, take $10 off of it, and you lose the disking cost, take another $10 off approximately. If these were rounded, they would all match. Take another $10 off, and you take off the plowing $10 per unit cost. And so really where we want to focus on the shadow prices are not in the balance constraints, which are going to have margin added. It's back here where the actual values are. So 190, take away the 10, take away the 20, that takes you all the way back to the plowing constraint, and you end up with that 170-ish shadow price. So be careful, right? That's the main thing, especially with a big model. So when we go back and do analysis, especially sensitivity analysis, with our big models that are linked up through these transfer activities, it's best to go back and think about them in blocks. Think about the block that still holds on to the 600 acres of the resource and work from that one. Then move to the block for the family labor. Move to the actual quantity information, not the transfer activities. So you be careful, do explicit interpretation that makes clear that you're not talking about a plowed, or the acre that's ready to go into the plowing activity is worth that, because it's not. It's only worth that here in plowing. Isn't a valuable activity, except for the fact that it allows it to be passed on all the way down to the fully prepped land. Right? So the value is not in the description here, it's that it makes its way down here. Right? So just be careful and be explicit, especially if you build one of these or build something like this in your own work or for your capstone. It's fairly standard to work from that first instance of the resource. So the first time you see the quantity show up of the resource, use that. That's probably the right context. There could be some cases where it isn't, where you have the option of doing something yourself versus thinking about a market where something comes fully prepped. And that's neither here nor there. But if you think about sort of food sales or something like that, you may have the option of buying raw product or partially processed. And so in that case, where there could be some sequencing going on, you might want to think about your margin internally, right? But you should probably account for it in budgeting as well and having a good look at that. The other piece that we could think about would be the coefficient ranges and the objective, and they make sense. They follow along with what you expect. The allowable increase and decrease, they're kind of interesting for the cropping activities, just like they would normally be, because they tell you right here, this is the shadow price on the wheat constraint. This says the non-negativity constraint, and it shows up here, basically, in both places. You penalize yourself $20 if you grow an acre of wheat when you shouldn't, or if wheat becomes $20 more valuable, you're now indifferent between growing one of these versus wheat. Okay, and that's really just the difference between wheat and the most valuable acre is $20 per acre difference. I rounded these. You can run them if you want to see what they are, but again, I kind of messed us over there with my cutting and pasting. Okay, so we've been through transfer activities here in general, for thinking about labor and trying to sort of supplement resources on the farm. And now we've thought about sort of some mini dynamics or in-period dynamics, really sequencing, right? Really matching up to the sort of truth of the process. In both cases, we discovered that we could take some simple model that was really just sort of budget oriented and probably oversimplified, and stretch ourselves back into the data and come up with some better sort of elaborations of a planning model. And that's what we've done. And now let's consider what we have, or what we've gained. We could consider now thinking about our crop model as a full set of sequenced activities, where we first plow, and once we plow, we're allowed to disc, and once we disc, we're allowed to plant, and we might make a choice to plant either X or Y. And then once we harvest, well, we can only harvest X only if we planted X. And then when we have that harvested crop, instead of saying we have this many acres that are worth this much money, well, if you have a transfer row, you could say 1 acre of corn is not worth $191 or whatever it showed up as. You could say it's this many bushels. That's my yield multiplied by the acres, and I have now B bushels. And what do I do with those B bushels? Well, I could sell them to the market, just like I sold my labor that one time in that one model, and get the spot market return. I could store if I have some capacity on the farm and think about future sales dates, and I would need to be thinking there about how fast does the market increase over time, right? So as you move away from harvest time, prices go up, but my costs go up. So there's some cost of storage I should be charging. And if I have the capacity, I could think about that, or hiring out storage. Or if we have some livestock on the farm, we can think about feeding it. Or you think about marketing our corn through an animal, right? Or through meat product, or milk, dairy. All would need to be done in sequence, and all would involve transfer from X to X, transfer from X to get the B bushels, the quantity. And then these B quantity of bushels we transfer to either a market activity to sell, a storage activity to eventually sell, but for some amount of time incur some cost of storage, and to be balanced off against whatever capacity we have, or transfer bushels into feeding. And that would take us into another model, right? We could go into a full detailed crop feeding or livestock feeding model where we say, well, you need this much corn, but it has to be balanced with this much soybean, right? And we could actually do it at the nutrient level. If we knew what the B bushels of corn whatever the activity X was, what are the nutrient qualities of it? You could pass it all into a diet model for your animals and get the pure cost of feeding there. And you have the cost of their diet. You'd have the marketing value of the animal, finished animal. So you can have a very detailed farm model. And hopefully, talking about all this in these sequences, one, makes you glad we're not doing all of that. But two, lets you know why, again, agriculture with this sort of multiple enterprise and the linkages between them and this sort of natural way of thinking about family-owned resources or operator-owned resources being employed is sort of a classic consideration. Okay, but consider further, because you will have to for your lab, that we focused in Module 2 in that 3-crop model. It was a different 3-crop model, but we said it could be important to split the labor availability up into seasons. I think it was maybe not pure seasons, but like 4-month increments. And by that, we were able to find that there was some trade-off in one period of labor because there was sort of a bottleneck, right? So we had too much work coming in. Well, now think about that in the context of Lecture 2 to 4 today, where we've said there's some labor available, and we might want to sell some labor or hire some labor, and we had a limit on labor, and we used all the labor. But in a sequence model where you have to have the labor ready during the period where you are plowing and disking to get the land prep ready, you could have plenty of labor on the farm. It just might not be available to you during the period when the land prep is required. And so in our lab this time, we're going to build sort of a synthesized model between lectures 2 to 4 to get some sequence in and think about what kind of bottlenecks there might be if we were a little more specific on not what the total labor availability is, but what are the sort of seasons or the periodic labor availabilities are. And that'll be our big lab exercise for this time. So taking some model pieces we have now, linking them together, and that'll be, I think that's what you're tasked with next. And that goes towards your assignment as well this time.